Good morning, guys. Welcome back to the third day of week 10, the last day of review. So this is what we saw on review day 2. We were seeing perpendicular and parallel lines, or parallel and perpendicular lines, where you are given two equations and you're asked to graph them and then determine if the lines are parallel, perpendicular, or neither. Okay. In this case, in the first exercise, we had two equations, y equals 3x plus 1 and 9x minus 3y equals to 12. Remember, we're using the intercept methods, which is the method for the standard form, even though the equation is written in any form, even if it's written in slope-intercept form or in point-slope form. In this case, we got a slope-intercept form equation and a standard form equation. For both of them, we did the intercepts. We decided which equation was going to be equation 1 and which one was going to be equation 2. We found the intercepts, we graphed them, and we determined that they did not connect, they did not intercept, so they were parallel lines. They had the same slope, but different intercept and y. Then the second exercise, we had y equals 1/2 x plus 3 and 2x plus y equals to 8. We also find the intercepts, and in this case, we found that we had perpendicular lines, okay? So they do intercept in one point exactly, which is this point over here. Okay, they connect in that point exactly. So that is the intercept, and the two equations, therefore, they form a 90-degree angle. Today, we are going to start review day 3. Today's March 10th, okay, 2022, and we're going to write equations. So we did it the other way around. In class, we did first the writing equation part, and then we did the graphing part. In this case, we did it the other way around. It doesn't matter. So for this new example, we're going to write a parallel line. Write a parallel line equation to the given one that passes through the given point. Okay, that will be our instruction. To write a parallel line equation that would be parallel to the given one and that passes through the given point, okay? So we are going to start right now. What's the equation that we're going to work with? The equation that we're going to work with is, I'm going to make it up. So this is y equals 3x plus 7. And the given point is going to be 2, -1. So you need to find an equation that is parallel to the given one. Let's rewrite that instruction, okay? Find an equation that is parallel to the given one. That sounds better, okay? Find an equation that is parallel to the given one that passes through the given point. So what are we going to do? We are going to use first the formula to find the slope, okay, that is parallel. For parallel lines, okay, let's do that prettier. So for parallel lines, we have that the slopes have to be the same. The slope of one equation has to be equal to the slope of the second equation, okay? So let's find the slope of this one. This given equation. We're going to call that equation 1. So that will be slope 1. What is the slope of the equation? Y equals 3x plus 7.
3.
3. Very good. So if M1 is 3 and M1 is equal to M2, how much is going to be M2? We can substitute. We can go ahead and say 3. Instead of M1, I use 3 equals to M2. Oh, okay, so M2 has to be also 3 because they have to be exactly the same. Okay, so we found already our slope. We have our point. How do we write the slope-intercept form equation? Or are we going to use another form?
The point slope form.
The point slope form. Very good. What is the equation for the point slope form?
Y minus y1 equal to m parentheses x minus x1.
Very good. And where do I find that x1 and y1? Obviously from the given point. So this is x1 and this is y1. And now we just go ahead and substitute the y1, the x1, and the m. So we are going to have y. Remember, since we have point slope form, we change the sign of the given number in the order pair. So y1 is negative, so I'm going to place it positive. And this is just to skip a step, okay? Equals m is 3, parenthesis, x minus x1. x1 is positive, so it was going to be minus 2. And that's it. You're not being asked to graph it right now. Okay? Questions? No questions. Okay. So we're going to do another one. We're going to work now with a perpendicular line because this is so easy peasy. So find an equation that is perpendicular to the given one that passes through the given point. So in this case, we're going to have 5x plus 2y equals 3. And the given point is going to be -7, 0. Okay. So now for the perpendicular lines, what do we know about the slopes of perpendicular lines? We know that if we multiply m1 times m2, we should get a -1. Okay, that's what we know. Now, this is a different equation, so we need to find m1. But in what form is written this equation? Can we find the slope just like that? Or should we do something else? What should we do?
We should find the slope.
Should find the slope, but how do I find it? How do I find it?
With the slope method.
With the slope method? Okay, how would that go? We only have 1 point. You only have 1 point. What should I do? I don't have 1 point. I cannot find the slope with another point, so I cannot use the formula y2 minus y1 over x2 minus x1. Okay, I cannot use the formula for the rise of and the run or the slope-intercept form because this is not written in slope-intercept form. This equation is written in standard form. So the first thing that I need to do here is to rewrite this equation 5x plus 2y equals to 3. I need to transform it. Since this is in standard form, I need to transform this into slope-intercept form. Okay, because I don't have it. I cannot find it. from a standard form equation. So you do need to transform this. So let's transform it. We need to leave the variable y completely alone in one side, okay, and positive. So this 5x is going to go to the other side with an inverse operation, which is minus. We're going to have 2y is equal to 3 minus 5x. Do we have the variable y completely alone and positive? No, not yet. So let's make it completely alone and positive. So this 2 will go to the other side, dividing every single term. So we're going to have y is equal to 3 divided by 2 minus 5 divided by 2 x. Now I can find the slope. What is the slope in this transformed equation? What is the slope in this transformed equation? Mm-hmm. Mm-hmm. This is the slope in that equation, guys. Remember, the slope is always the coefficient of the variable x. What is the coefficient of the variable x in there, in here? What's the coefficient in there? In other words, in simple, non-technical mathematical words, what is the number next to the variable x? That's the slope. So what is the slope in this case? Negative 5/2. Negative 5 over 2. Let's move that, make some space because we don't have enough space in there to write the number. So we said that it is negative 5 over 2. Okay, so we found already the slope 1. We found slope 1. Now we find slope 2. So if slope 1 is negative 5 over 2, I'm going to substitute it in this equation. So negative 5 over 2 times m2 should be equal to negative 1. Now remember, I told you already, when there is a fraction that is multiplying, like in this case, it's multiplying m2, sorry, you are going to continue to multiply, but what are you going to do with the fraction?
Flip it.
You're going to flip the fraction. Very good. Okay, this is the only case we do that. Remember that. Don't forget it. So we're going to say that m2 will be equal to negative 1 times, instead, negative 5 over 2, negative 2 over 5. Okay? And I go ahead and multiply. So m2 is equal to negative 1 times negative 2. Negative 1 times negative 2.
Positive 2.
Positive 2. And nothing times 5? 5. Okay? So m2 is 5/2. Okay, so now we do exactly the same thing that we did over here. Okay, where we find our equation by substituting in the point slope form. Because I got my slope and I have my point. So let's do that, okay? So we have y minus 0, because y1 is 0. Remember, this is x1 and this is y1. So y minus 0 is equal to m, the 2/5 that I found, parentheses x minus x1. x1 is negative 7, so plus 7. And I close parentheses. Now question, do I actually need that zero that's over there? Do I really need it? Do I really need this zero that is subtracting? No, right? I don't need it. Y minus 0, it's still y. So I can say that y is equal to 2 over 5, parentheses, x plus 7. Because I don't need that 0 in there. Because if you have 10 lempiras and I give you 0, how many lempiras are you going to have? Still 10. Now, if you have 10 lempiras and I borrow 0, how much are you going to have? Still 10. You're not taking out, you're not giving. So it's still the same number, even though you're adding 0. Okay? Questions? No questions. We're good. Okay. Let's do one more exercise. In this case, you guys are going to do it by yourselves. Okay? We're going to do one more. We're going to make it double. Okay, we're going to double it. What does that mean? That you're going to find from one same equation, one parallel and one perpendicular line. Oh, okay. Someone is asking why the 5 has the negative sign when we passed it. If at the beginning it was the other 2. It doesn't matter. Remember, you can have negative 5 over 2. That is the same thing as 5 over negative 2. And that is the same thing as negative in the middle, 5 over 2. So it doesn't matter where the sign goes. It can be with the 5, it could be with the 2, or it could be in the middle. At the end, it is the same number. Okay, so it doesn't matter. That's why I wrote it over here with a 2, just to keep the negative in the numerator. Okay, but it doesn't matter. Okay, now I'm going to move you to the other side. I'm going to rewrite my exercise. And I'm going to say, find an equation that is perpendicular and an equation that is parallel to the given one that passes through the given point. And what is going to be my given point? My given point is going to be 5, 3. And my equation is going to be y plus 2 equals 2, 7, no, not 7, equals to 1/2, no, 1/3, parentheses, x minus 9. Okay, that would be your equation. Y plus 2 is equal to 1/3, parentheses, x minus 9. And we need to find an equation that is perpendicular and another equation that is parallel, perpendicular, okay? And it passes through the point 5,3. So we have to find 2 equations that pass through the same point, but that one is parallel to this one and the other one will be perpendicular to this one, okay? Besides being perpendicular to this one, it will be perpendicular to the other parallel one that we're going to find. I'm not asking you to graph it or anything, but it's just information, okay? So, first thing, let's say that we're going to start with the perpendicular because that's the first one that appears in my exercise, okay? So remember what we said, m1 times m2 is equal to -1. That's how I know that they are perpendicular. So I'm going to find m1. How much is m1 in this given equation? How much is m1 in that given equation?
1/3.
1/3. Very good. How do you know?
Because it's the slope. It's next to an x.
And in what form is this written actually? Is this a slope-intercept form?
Point slope form.
This is written in point slope form, and the slope is the one that goes outside the parenthesis. That's multiplying whatever has the variable x on the inside. So very good. So M1 is 1/3. So I'm going to find my M2. So I have 1/3 times M2. I'm just substituting is equal to -1. So I'm going to pass this 1/3 to the other side, multiplying, but since it is a fraction, I'm going to flip. Only when it is a fraction it's passing to the other side is that we multiply. If it is a whole number or a negative integer, then you pass it dividing, okay? So we're going to have now M2 is equal to -1 times, instead of 1/3, 3/1. Okay? And we go ahead and multiply. So M2 is equal to -1 times 3, -3. Nothing times 1, it is 1. Do I need to have a denominator 1?
No.
So I don't write it. I leave it like that. M2 is -3. Okay, so now I'm just going to use this formula, because this is always the formula that we use, the point slope form. And I'm going to substitute. I'm going to say y1, remember this is x1, this is y1. It is positive, so I say y minus 3 is equal to -3, that's the slope, x minus 5. Why am I doing it -5? Because 5 was positive, so I keep the minus. And that is the perpendicular equation. This equation is perpendicular to the given one. Let's go with the parallel one. Okay? So let's begin again. What is the formula for parallel equations? What is the formula for parallel equations?
M1 equals to M2.
Very good. M1 is equal to M2. Since we found already for the first part the M1, I just go ahead and copy it because I found it already, okay? I know already that it is 1/3 because I'm using the same equation, right? So if M1 is equal to 1/3, that means that 1/3, doing the substitution, is equal to M2. And I found my slope 2. Now again, I'm going to use the point slope form equation and I'm going to substitute. I'm using exactly the same point. I'm just using a different slope. So I'm going to say y minus 3 is equal to 1/3 x minus 5. And that's it. This is the perpendicular equation. This is the parallel equation. Questions? Questions?
Miss, I have a question, Miss. If we want to graph, how we can do it?
You have to graph, then we use it with the intercept methods, okay? We find the intercept of the given equation, and we find the intercept of this equation. Okay, so this is not exactly the exercise that you have, but we can say that the fraction, that the equation might go, that's our coordinate plane. They're both positive, so probably it goes something like this one, and probably this one goes, no, the other way around. This one is like this one. And for this one, since it's negative, it has to go something like that. Okay, for that one. Now for this other one, if we did the graph, probably it goes something like this. And something like that, because they're both positives, okay? The denominator would be -1. In which part? In this one, in the slope? No, it's not -1 because we already multiplied -1 times 3. You don't have another negative. There's -1 times 3, and you have nothing at the bottom in the denominator. So nothing times 1, it's still 1. So not -1. If you had over here a -1, then yes, negative times negative, positive, sorry, will be negative. But in this case, you don't have another negative sign. You only have 1, which you already multiply times a +3. Okay, so that's how you would graph it using the intercept methods. This is just a little sketch, so probably it goes something like that. Okay, any other question? No? Okie dokie then. This is the very last part of the review for the exam that you have on Monday.